So, yeah, I'm Charlie Zender, and I have been working with the infrastructure group, I think, since the beginning-ish of Acme E3SM. And during that time, I have come to really appreciate the CF conventions that are better integrated already with the atmospheric model than with the MPAS models. And so, after running into some obstacles and working around them, a few years ago, Seiler and a former postdoc of mine, Wenshan Wang here, uh, began some epics that reached the pull request stage and are almost ready to go into, I guess, full um, E3SM integrated MPAS. So users will actually benefit from it. And this talk is great because it means there's still action on this and that work that Wenshan did before Enzyler has not been in vain, and it's great to expand that community. And my goal in the talk is to try and explain some of the basics of CF, why they're useful, and on a more practical level, how we might sort of aspire to leave this hackathon. And in that sense, I'll be talking about the the transformation of the current MPAS output to what I think would be a much more CF compliant MPAS output. You can ask questions at any time. And I also wanted to acknowledge Henry, who wrote the CF parser, sorry, the CDL parser in NCO, and Daniel and David, who are heavily involved in CF itself, as I have been, but not for as long as they have been, and then Brian Eaton from NCAR. So picking up with a little bit of history, and I'm sorry that these are all virtually completely text slides. So the story of CF began in the late 1990s when Brian Eaton and Jonathan Gregory, whom I think many of you have worked with at Reading, decided that the MIPS, I think it was the second annual report at the time that NCAR and UK Met Office and Reading were contributing to, needed to be intercomparable, needed the members, the modeling contributions to be more intercomparable, and how would they do that? And so they had a series of one-on-one meetings, and that led with the contributions of many other people, including DOE people, to CF. Um, Trivia note, I kind of acquired most of my CF early knowledge because Brian Eaton and I sat in the same office area at NCAR when I was a grad student. So I was an early tester of CF because I was writing NCO at the same time. Okay. It has been used and probably is most well known because of its use in CMIP since nearly the beginning. And for many years, it was just volunteer based, kind of like this hackathon. And it was hosted by DOE at PCMDI. Carl Taylor has played an enormous role in CFs since the onset. It has been based on NetCDF3, and that was true until a couple of years ago. That was actually my contribution. Another trivia note, moving some NetCDF4 elements into CF. And we have annual meetings where we discuss issues and governance and things like that. And the next one, I think some of you came to the last one. The next one is this summer in Santander, Spain, in September. Okay, so here, and for the rest of the talk, which I will try and keep to a half an hour, um, I would like to go through in order of sort of, I think, ease of understanding and increasing order of abstraction, some of the important concepts that let's put into MPAS. We all have the buy-in, so I don't necessarily need to say much about the use. I will try and say something about the end utility of these modifications, which I would call enhancements, and in some cases improvements, at least for the end users' lives, not necessarily for the developers and researchers. If you can distinguish those three categories, then then we're on the same page. Um, okay, so for units, and I'm going to say right off the bat that I'm not going to say anything about fill value because it just we've been talking a lot about it, so kind of ripped that out of this presentation. So the next most basic idea here is units, and the CF convention relies on the UD units package, the software package from Unidata, for all units. All things units are actually handled um, basically by UD units, meaning the acceptable units are all defined in the UD units package. There's a link. You can click on it. There's also a collection of links at the end of the presentation on the very last, second to last slide. So you'll see here an example. It's just a screenshot of how you might go about making sure that your units are CF compliant, basically by using the UD units tool. Because remember, that means the interpretability of units by UD units means they are CF compliant. So here's an example that I actually used on MPAS output. If you have UD units installed, which is in E3SM Unified, you can run the UD units tool. It asks you to type in the units that you have, and it will translate those units to any units you want. And so for things in MPAS, which was clearly written by LaTeX-loving people, uh, you'll get don't recognize errors if you use braces. And so if you replace that with the non-brace version, do the minimal change necessary, all of a sudden it doesn't complain, and you can translate those units into any units, and it tells you how to do the translation. And then the key for the next few slides is I just took some screenshots of the diff between the CDL output of the existing current MPAS files, or a sample file that Carolyn sent me, and what I suggest as the kind of target level of compliance for CF. And so the reds indicate lines that were taken out or taken out, and the green lines are lines that were placed in. And so that just shows in a very quick way what was done to change the units of the Coriolis parameter. So a couple of corner cases. Who doesn't love corner cases? Okay, we got a couple of these examples in the sample file, so these are actual changes. If a unit has no units, then CF assumes it's dimensionless. However, if you run the CF checker, you'll notice what happens is, so here I've removed the units unitless, which is not a CF compliant unit. Just removed it as indicated by the red less than sign from a diff. And the CF checker on that does give an info warning or an info message, so it's not a warning. And there's really no way around this. I consider this a defect of the checker. It's really not a defect. I mean, it's a helpful reminder, but if you want a clean check, then, it's kind of a defect. So don't worry about these is the message. If the variable is not supposed to have units. Okay, the next example shows how CF handles fractions. So instead of putting in the units something like grams of salt per kilogram of seawater, which was done or is done for salinity, I took out those existing units and replaced them with this funny unit, 1 dot E minus 3. And that's because the standard variable name for this quantity, correct me if I'm wrong, is seawater salinity. And I moved the explanatory text, grams of salt per kilogram of seawater, into the long name instead. So my goal in doing the modifications that I suggested was to kind of preserve the the informative parts of the current implementation while moving towards CF correctness. And that's what happens. We'll talk about standard names in a minute or two, but um, suffice it to say that the recommended units are grams per kilogram for this variable, and so it's a perfect use of the standard name. Okay. We're going to talk about exactly what we mean by coordinates, but for the geophysical quantities, longitude and latitude, if you have any variable that contains those horizontal dimensions, the recommended units are degrees north and degrees east. So there would be a problem probably in analysis software if we just changed the units of the horizontal coordinates in MPAS from radians to degrees. And so I don't think anyone wants to go down that path without a bit more thought than I was able to put into it. So I left it and I just put this message in that sample CDL file, which, to remind you, is sitting right here. So this is the starting point CDL file on the discussion page. This is the endpoint CDL file. Oh, well, it was the endpoint CDL file until recently. Huh, interesting. Anyway, these are text files. You can download them and look at them on your screen. And so I didn't change radians. I just wanted you to know. Sorry, I'm doing things wrong. I just wanted you to know that that's maybe something to think about. It'll pass the CF checker because radians are known units. It's just not CF compliant to have them as units for the horizontal coordinates. Um, Time. Okay, we've talked about time. I think everyone through usage has acquired an understanding that an annotated time variable will look something like this, and it will have a time unit, sensor reference time, and then a calendar as well. We haven't talked a lot about calendars, but they're pretty intuitive and they're also pretty complex, so I won't go into them. Here are two uses of units in kind of real world situations. Hyperslapping is one. So if you have your time units in your MPAS output files, think of, I don't know, daily means, a time series of daily mean values in an input file. If you're using CF compliant time units, then you can hyperslab by the CF compliant notation. So you could get 2 years of daily data out of your input file and into your output file and leave the rest behind, for example. For non-time units, it's even simpler because you don't need to know the CF compliant way of representing time, but it's pretty intuitive. So for 1D for what are known to CF as true coordinate variables or just coordinate variables, meaning variables that have the same name as an underlying dimension and they're one-dimensional, then this kind of format works and you could get kind of equatorial mean, and so hyperslabs using latitude and longitude coordinates. This isn't the case with MPAS. It is the case with regridded to rectangular grid outputs, so it does still have real-world significance for MPAS users. MPAS natively writes what are known as auxiliary coordinate variables that we'll define in a second. And hyperslabbing can also be done on those. And so, for example, if you wanted to grab all the points in the same region with an auxiliary coordinate variable, especially for an unstructured grid like MPAS uses, you can do these south, north, east, south, north, west, east kinds of groupings where the underlying variables are auxiliary coordinate variables. And we'll define that just in a couple minutes. So users find it useful to have your units in CF compliant formats. That's the take home. Okay, next, there were a lot of issues. Well, let me stop there. Were there any questions about units, or we can discuss later?
Can you say a little bit more about the auxiliary units?
Okay, I
Auxiliary
will
coordinates?
later, I promise.
Okay,
What I can say, Adrian, is that I did skim over one thing, and that is for every hyperslabber that I'm aware of to use these units, you need to distinguish the fact that you're asking it to use the underlying coordinate variable of whatever type by giving it a decimal point and not using an integer. Integers are interpreted as indices into the underlying arrays, not as the values of the coordinate variables. So, but now, remind me if when we get to coordinate variables, I don't explain it well enough, Adrian, please.
sure, will do.
Okay. Okay, standard names. This is one of the most active areas of CF because everyone has a new thing they want to output and put in a standard name table, which I've linked here. It's a very useful place to go. And so for all of those little JIRA tasks of finding the standard names, one approach that I find easy is to go to the standard name table, linked here, search it for the keywords in your variable. Here I was using Coriolis, and then it brought up the standard, the variable whose name contained Coriolis, and it turned out that the CF name for the variable that MPAS stores as fcell is Coriolis parameter. So then I just added, and that's why this is all in green. This is all addition. There's no deletion of the original. I'm just adding a new attribute called standard name, and the standard name is the Coriolis parameter. The standard name table will give you the canonical units of the variable that CF kind of prefers. And for the salinity example, the canonical units were grams per kilogram. And MPAS already used those units, so great. And the canonical units for Coriolis force are, of course, per second. So that's fine. But there may be cases where it's it's not too disruptive to your users or to analysis software to switch the units from what's currently output to canonical. I haven't encountered any cases. Maybe we will during this hackathon. Okay, so here we are on coordinates. And Adrian, you can exhale now. So this is a subtle area. It still gives me, sometimes I have to go and read the definitions again. But to recap, um, any variable that's 1D with the same name as its underlying dimension is a coordinate variable. So that's pretty straightforward. And the time variable is usually a coordinate variable. And for rectangular grids, the horizontal dimensions are usually coordinate variables, lat and lon, like just like this. And so in most of regridded output, you'll see something that looks like this. Um, so we got the appropriate units. We have a standard name of latitude for the latitude variable, a long name. And then to help plotting, not PLODDING, but PLOTTING software, you can add these labels, these additional CF labels, to let software know that, hey, this is something that we usually put on the x-axis, y-axis, or z-axis. And so a lot of regridded data that you'll see also has these labels specifically on the spatial dimensions, just to help plotting software. In other words, um, kind of automated plotting software figure out, like NCView might use this information. Okay, so the difference between 1D coordinate variables and other coordinate variables that are called auxiliary coordinate variables are that these auxiliary ones are much more flexible and are in fact required for curvilinear coordinate systems, where your horizontal coordinates are actually functions of um, latitude and longitude. So you have 2D arrays for latitude and 2D arrays for longitude. It's also the case for unstructured grids that their spatial coordinates are auxiliary because the variable name is not the same as the dimension name. And for these unstructured grids, multiple variables use the same dimension. N cells for MPAS and col, C-O-L, for EAM. So you'll have longitude with the col dimension for EAM, and you'll have lat cell N cells for MPAS. Okay, so this is, all we've basically done is a definition here. Lat cell and lon cell are auxiliary coordinate variables. They play the same role as latitude and longitude, and so that is the correct standard name. So um, when an application software inspects your data set, your MPAS data, and it doesn't know, hey, what's latitude in this data set, there are a few ways that CF compliant software will identify latitude variables and longitude variables. And one of the ways, the easiest way, is just to look for the standard name latitude. And so that is, in fact, how we would like that to occur with MPAS. The other way is to give your variable the units degrees north, but we can't really do that with MPAS because of the radians issue might be too deeply embedded in analysis software at this point. Anyway, that's something for you all to decide. So you want to give these a standard name of latitude and longitude for sure, and the new recommended outputs do that. I guess I'll ask Adrian, does that make clear what auxiliary coordinates are?
Yeah, absolutely. Thank you.
And let me back up 2 slides so that you see this format, at least for NCO, this auxiliary expects the horizontal dimensions to be auxiliary coordinate variables. And it will go dig through and look for the standard name latitude and longitude in the input data set. Failing that, it will look for degrees north and degrees east and figure out to what auxiliary variables these bounds apply. And that's how that works. It uses the CF conventions. Okay, so things are a little bit simpler, but not as flexible for 1D coordinate variables than for auxiliary coordinate variables. And that brings with it kind of the burden of letting fresh-faced, naive, young MPAS wannabes, um, of the burden of helping them understand your data. And the way to do that when you're using um, auxiliary coordinates instead of coordinate variables, from which auxiliary coordinates, it's hard to figure out like what is the latitude, what are the horizontal spatial coordinates that define this variable, temperature, for example. It's kind of hard to tell because n cells might there might be 50 one-dimensional arrays of dimension n cells in an MPAS output, all what we might call 2D variables or unstructured 1D variables um, are n cells. And so how do you find out what the horizontal spatial coordinates are? This is where the coordinates attribute comes into play. It's not necessary to use this for 1D coordinate variables because the dimension names define those coordinates unambiguously. But for auxiliary coordinate variables, that is not the case. You can have a bunch of variables whose dimension is n cells. So you tell the world that these two variables, not any other variables, are the horizontal coordinates for this variable. We don't need to add time into the coordinates because time will be a 1D coordinate variable, and so that's unambiguously determined anyway. I did not add n vertical levels because that is a dimension, not a coordinate. So there's kind of a lot to think about there. Why don't I pause and see if there's any immediate questions?
Does the order of lat and long matter?
It does not, although to some software may erroneously assume that the variable's dimensions, spatial dimensions, um, some follow the ordering of the coordinates attribute. That is not the case, though. There's there's nothing um, intended to be implied by the ordering. And that is true of most of CF, by the way. When you see these attributes that have a space-separated list of things, nearly always the space-separated list has to be considered to be unordered. Great question. Okay. So we're about to do a level up in abstraction. And really, if MPAS became CF compliant in the ways that we've already discussed, I would consider the hackathon a success. Here are here are the next lowest hanging fruit, in my opinion. We're going to talk about cell methods and then cell measures. How am I doing on time? Here, let's
Um,
see.
so I think there are a few folks that have had to head out, but I think we're fine as far as I'm concerned if you want to
I
go
just
in a little bit.
Well, I just hit, I'm over, I just hit 30 minutes, so if you say so. I got two more slides.
No, go ahead. Do the two slides. I think that's fine.
Okay.
If folks have to take off, that's understandable.
So, these are going to sound similar in name, but they have different meanings. Cell methods first, and then we'll talk about cell measures second. So, cell methods describe the statistical properties that you can assume the contents of a cell represent. So the value of a cell represents, it could be, the minimum along a given dimension, the maximum. Normally, you're going to see these in E3SM land as being means or points. So points for instantaneous time or spatial locations, okay? And means for most everything else, but not necessarily. Of course, the climate analysis community is interested in mins and maxes quite often. And so this is where we encode in the cell methods attribute what we've done to a variable's values along each dimension. And you are in CF recommends doing this for every dimension in your variable. So snow flux, I've given 3 examples. These are not supposed to be, only one of these should appear for any given variable. Okay, I've given 3 options here. The first, so we're going through the dimensions in the variable. Time is a mean. So MPAS variables typically output time mean values within a time step, I assume, or within a month, or within a day. It's the time mean. If it's not, then you use one of these words. But for time, really, it's either a point or a mean. I don't think there are any other options. And then area is really a shorthand for using lat and lon separately. And this is a useful shorthand because, for example, MPAS doesn't have lat and lon dimensions. So, CF is aware of that, and there's this special exception. So for the spatial area, for variables that represent averages over the spatial area, which is basically true of FV models, finite volume grid cell models, then you would just say area instead of lat and lon, or N cells, I guess, in this case. So the where clause restricts the area type. This is something new to me. I only learned this, in the last 24 to 48 hours because I typically haven't modified this stuff for Elm or MPAS before. But you'll see if you look at the ESMF distribution of CMIP data, in fact, that the ocean data, including MPAS data, gets processed or CMARized into this kind of format. So the ocean model will have where sea, and the sea ice data will have where sea ice. So for any variable whose value represents an average over sea ice when sea ice is present, then you would have where sea ice. And you can see how this is very applicable to virtually, I think, all MPAS models and Elm as well. And Elm is guilty of not doing this correctly, by the way. So you can one up those Oak Ridge folks if you want.
So quick question,
Mhm.
do we need to define these area types somewhere, or are they already defined somewhere if we were to use them?
That's a great question. I I'm not 100% sure. This is a great start. There are ways of defining area types. I can tell you that. Um, you can also have regional types. So, for example, you can name regions like North Atlantic. And so, for some of the analysis members, this cell methods is going to be very useful for users to be able to understand what a variable represents without having to have a 97 character variable name that says time monthly average temperature North Atlantic. You know what I mean? So the cell methods is where that kind of is intended to be, those regional restrictions and aerial constraints are meant to be indicated. There is in the CF document pretty extensive documentation of where, and the valid area types are sea and sea ice and land over or ice over land and then ice over ocean, and there's all sorts of like for solid ice. And so it does behoove some MPAS people in this hackathon to look more deeply into that. And I'd be interested to see and help parse those conventions.
Thanks.
Okay. The last example here shows, and this is already used with by NC Climo and generating climatologies. This is an example of how the time dimension, especially, can have multiple averaging applied to it. And so for climatologies, this is from a seasonal climatology. For example, a JJA, a summertime average of time monthly averages, it'll be the June-July average within a given year. So time mean within years. And then the Climo averages those June-July averages over years. Oops. So that's how you indicate that. And that's what NC Climo will annotate those output variables with. Okay, I guess I've beaten that horse to death. I learned during the evacuation of Los Alamos regions during the fire that horses are odd-toed ungulates because one of my former postdocs works at Los Alamos and has a couple horses. So that's a factoid that I dropped in for no particular reason. CF does not yet regulate that nomenclature. Last one, last slide, cell measures. Okay. So what this does is it tells users to what variable the properties of a cell can be, the area of a cell and the volume of a cell can be tied to. Okay? So to what variable the actual areal extent of a grid cell can be tied to. And so that's certainly applicable to many models. So for a temperature coordinate, you might have a cell measures attribute that tells the user and the software that the area of each grid cell in this data set is represented by the following variable, area cell. And then your area cell variable, which does not need to be in the same file according to CF. So this is how the CMIP archive avoids putting area in every single time series file. This variable, area cell, is actually called area cell O for area cell ocean in CMIP language, and it's in a separate standalone file. But for your raw output, area is in the same file, and it will have a standard name when we're all done of cell area. And so that's how you tie the area represented by a grid cell to a variable. I don't know that we should do anything with volume because there is no volume variable in MPAS output. So I refrained from suggesting one because, of course, the amount of space that would imply is quite large, and it's fine to not have volume, but CF certainly has defined volume. So you could have volume colon and then some volume variable. So people understood, oh, the salinity applies to this amount of seawater indicated by the volume held in this volume variable to do, for example, total budgets. And I think that's it. Yeah.
Great. Thank you, Charlie. That's fantastic.
Great. Glad that's over. You can
You wanna
stop
stop
recording or we if there are no questions.
Sure.
Yeah, so folks who are online, just unmute yourself to ask questions. That's a bit easier than the chat.
I'm not sure if this is a question or a comment, but I mean, like Adrian, I was very interested in the auxiliary coordinates
Mhm.
for MPAS data because I found before trying to hyperslab data uh, by by region or whatever is very difficult because the dimension is n cells and lat cell, lon cell are variables, and I couldn't figure out a way to get NCO to splice or to extract data in a given lat lon range because of that. Um, so this
Yeah.
I would find very useful.
Yeah. So for NCO, if you're referring to like commands
Mhm.
like this, we do
Yeah.
use these, especially in EAM output, because EAM has the ability to output, an unstructured grid, a cube sphere representation of rectangles. This is restricted to working on rectangles, but there can be an arbitrary number of these dash X arguments. So if your funny shaped region requires more than one rectangle, it will work. But this is not a solution for highly irregular regions like, the North Atlantic. For that, you need a mask.
Hmm.
Great.
Mhm.
Any other questions?
Okay, I will stop recording then. Thank you, Charlie.